A pilot is flying over a straight highway. He determines the angles of depression to two mileposts, 5 miles apart, to be angle x equals 32 degrees and angle y equals 48 degrees, as shown in the figure. Round your answers to two decimal places. A, find the distance of the plane from point A. B, find the elevation of the plane. So let's go ahead and put some numbers into the figure. We know that the angle of depression for angle x is 32 degrees. So that means this is 32 degrees right here. We also know that the angle of depression for angle y is 48 degrees. We're then told that the distance between the mileposts are 5 miles. And so what we want to do is we want to determine the distance from the plane to point A and then find the elevation of the plane. So let's go ahead and find this value, this distance, and let's just call this side B. And so that's what we're looking for. Now, there's a couple things that we can look at here. First off, since the line of sight right here is a straight line, we know that any angles formed off of that straight line will be supplementary. We are told that x is 32 and y is 48. So if we add 48 and 32 and get 80, we know that the angle between them right here will be 100 degrees. In addition, we can also figure out what these base angles are right here at angle 1 and angle 2. Simply because we're going to use geometric principles. These two lines, here and here, are parallel. And we will go ahead and use the symbols for parallel lines from geometry. And we also note that in this case, this line from point A to the plane, which we're calling B, is a transversal, and it cuts between two parallel lines, which means that alternate interior angles are equal. So this must also be 32 degrees. Likewise, from point B to the plane, which we're going to call side A, is a transversal cutting between two parallel lines, and alternate interior angles will be equal. So now I know that the interior angles of the triangle are 32 degrees, 100 degrees, and 48 degrees respectively. So now we can use the law of sines. Remember that the law of sines, as stated, sine A over A equals sine B over B equals sine C over C. And what we're going to do is we're going to use just two components of that to solve for a missing piece. So when we say sine A over A, what we're talking about is the angle A and its side opposite, which we will name A. So in this case, if angle A is right here, we've already labeled this as side A over here. So now let's go ahead and determine what it is that we're actually looking for. So we're given the fact that this, and we're going to go ahead and call this point P up here. So I know this point P here, and angle P is 100 degrees, and then the side opposite is 5 miles. So we can simply state that the sine of 100 degrees over the side opposite of 5 will be equal to, now remember we're looking for this side here, B, and so we're going to use angle B here, which is going to be the sine of 48 degrees over the length of side B. And now, since this is simply a proportion, I can go ahead and cross multiply sine 100 degrees by B and get B times the sine of 100 degrees is equal to, and then I'll multiply 5 times the sine of 48 degrees. But remember, I want to know just what B is, so I will divide both sides of this by the sine of 100 degrees. And then I can simply state that B is equal to, and I'll do the calculations. We'll go ahead and write it out one more time just to make sure that we know exactly what we're going to punch into our calculator. 5 times the sine of 48 degrees over the sine of 100 degrees, punching that into the calculator, and you're just going to go ahead and type it in exactly as it's written, but make sure that your calculator is in degree mode and not radians. And so we end up with B being equal to 3.77 miles, which means that this post at A right here is 3.77 miles from the plane. Now the next thing that we want to do is go ahead and find the elevation or the height of the plane. And we'll go ahead and use a fresh diagram to do that. Once again, I'm going to go ahead and plug in some values, and this is what we have. So in order to find the height, we're actually talking about the altitude. So if we draw an altitude or height down from the plane so that it is perpendicular to the ground, we now have a right triangle. And so we can use our trigonometric relationships to easily solve this one. We know that we have this angle of 32 degrees here, and this is going to be your opposite side, and this is your hypotenuse. So then we can go ahead and say, to find the opposite side, which is what we're looking for, this is going to be the sine 32 degrees is going to be equal to the opposite side over the hypotenuse of 3.77. Therefore, the opposite side is equal to 3.77 times the sine of 32 degrees. And then we just punch that into the calculator, and 3.77 times sine 32 degrees is equal to 1.9977, and therefore we're going to simply round that to 2 miles, because we're going to round to 2 decimal places. So as I said, this is approximately 1.9977, which would round to 2 miles. So therefore we know that the plane is 2 miles off the ground. That's the altitude. So right here we can go ahead and say the distance is 3.77 miles. The altitude is 2 miles. Now, since this is an application problem, you would want to write this as a sentence.